Last example, what is different about this compared to the other functions that we've looked at? It is a rational function. Thank you. It is a rational function. So, parent share, see if you can say anything at all about this rational function. Go, talk. Five, four, three, two, one. Okay, what can you tell me about it? Anything. Tell me something. Very good. There is a vertical asymptote at x is equal to -2. Let's talk about that, okay? Let's talk about the horizontal asymptote. The vertical asymptote is x equals -2. The reason why is where is it undefined? At x equals -2 is where it's undefined. That is an x value, thus it is vertical. Get that? Now, let's talk about the horizontal piece here that you're looking at. The horizontal piece is going to come up with the end behavior. If we take the limit as x goes to infinity of 3x over x plus 2. We'll review how we do this again. What can you factor out of the top? And you get times 3. What can you factor out of the bottom? X. And you get 1 plus 2 over x. As x goes to infinity, what's going to happen to 2 over x? That's going to go to 0, and the x's cancel, leaving you with what on top? 3 over 1. So as x goes to infinity, okay, the height of the function is going to be 3. So that's the horizontal asymptote, the end behaviors we had to the right. And if we did the same thing, limit as x goes towards negative infinity, you would get the same thing. You would also get 3. So the horizontal asymptote is y is equal to 3. So the vertical asymptote where it's undefined, the horizontal asymptote is its end behavior. Does that help a little bit? Good. So that's what we know. I'm going to wait to kind of start making the graph. Intercepts, we talked about those. The x, let's talk about the y-intercept first. Yes. So if we did the same thing, okay, if we approach negative infinity, you would still get this same result, wouldn't you? And notice how the x's cancel, and it's just 3 over 1. And if you ever wanted to check your work, it's a really good question, Mr. Chalmers, is if you plug in a large negative number, so you plugged in a large negative number in the top, what are you going to get in the top? A large negative number, and what are you going to get at the bottom? And a negative divided by a negative will be, so see how, if you just try that practice, see how you can confirm what you're going to get? It's always a good way to kind of glance at it. The y-intercept happens when? When x is 0. If we plug in 0 for x, we get 3 times 0 over 0 plus 2. So we get 0 over 2, which is 0. I maybe don't have the best example here. I'm kind of regretting it, but we'll try to put 2 pieces together. In order to find the x-intercept, what do? You set the function equal to 0. So 0 equals 3x over x plus 2. Now, a fraction is equal to 0 when the top is 0 or when the bottom is 0? When the top is 0. When the bottom is 0, we say it's undefined. That's where we got our vertical asymptote. When the top is 0, that's when a fraction is 0. Agreed? Well, when would the top be equal to 0? At x equals 0. So notice it does go through the origin. If I could just show you a small different example, suppose it was, say, 0 equals 5 minus x over x minus 1. You can see there, where's the vertical asymptote? X equals 1. And then for the x-intercept, okay, when is the top equal to 0? 5. So that's how you determine that. Does that help a little bit? Okay, good. Excellent. Well, it looks like we've got some really good pieces here. We know it goes to the origin. We've got horizontal and vertical asymptotes. In order to do these, what do I have to do? First derivative. Let's start with the first derivative. Excellent. We got the quotient rule. Fortunately, you're really good at that. Remember, we used to practice the quotient rule all day long, and you're like, wow, this is super tough. Now it's just easy stuff. We got 3x over x plus 2. And so we want to find f prime of x. Derivative of the top. 3 times x plus 2 minus 3x times 1. Good. All over what? Good. How will the top simplify? Good. So 3 times x is 3x, and 3 times 2 is 6. 3x's will cancel, leaving you with 6 over x plus 2 quantity squared. That's my first derivative. What do you notice about the first derivative? Okay. Very good. We'll give you a chance to see it. Is the top ever equal to 0? No. Is the bottom? Where? -2. Now, you know how sometimes, like in the past, we've graphed that first derivative, right? And we graph the second derivative. I'm guessing that most people don't know what that graph looks like. So since you don't know what it looks like, let's do what we call a number line test. We're just going to mark where the top or the bottom is equal to 0. The only spot is -2. And we're just going to test a number. Give me a number to the left of -2. -4. Okay. So what's -4 plus 2? -2 squared, 4. And 6 over 4. So is that positive or negative? So see when you plug in -4, you came up with a positive value. Let's test another number. Give me a number to the right of -2. I like 0. 0 plus 2 squared, 6 over 4, still positive, right? So you can see that you don't even have to look at the graph. If you don't know what the graph looks like, you can just do a number line test. So what this tells me is if I plug in a number on this side, it's positive. If I plug in a number on this side, it's positive. Does it make sense now when you look at it that this is always positive? Because the top is always positive, and the bottom, when you square something, it's always positive. So what does that tell us? So it's always, so the first derivative is always above the x-axis. What does that tell us about this stuff? It's always increasing. It's increasing from -infinity to -2, union -2 to infinity. No, you can't, because -2 is not part of the domain. Yep, very good. So we got to get rid of that -2. Is it ever decreasing? It's never decreasing. When does the local max happen? When the first derivative changes from? Does it change from positive to negative? No. So there is no local max. When does the local min happen? When it changes negative to positive. So that never happens either. So there's no local min. So I recall that that's the information that we gather from the first derivative. All good? All right. So second derivative, we have to take second derivative of this guy. So we're going to do f double prime of x is equal to, and I would like you to have a brief conversation with your peers how you would attack taking that derivative. Go, talk. Five, four, three, two, one. Okay, here you go. Can somebody tell me how would be the most efficient way of taking that derivative? We know that the quotient rule is an option, but is there a better option? Yeah, if you write this as 6 times x plus 2 to the negative 2 power, everybody agree that those expressions are the same? And I would like to then use what rule? See how the chain rule is nice and easy there? So I'm going to use the chain rule. What goes on the outside? Good, 6 to the negative 2. And then on the inside is x plus 2. Derivative of 6u to the negative 2. And what's the derivative of x plus 2? I multiply these, and I get negative 12 over x plus 2 quantity cubed. So that's my second derivative. Now, what's interesting about the second derivative is that it's not always positive or negative, is it? When you cube something, if you cube a negative, it becomes negative. So we're going to need to test this. And if you don't know the graph, don't worry. Just test values. So I just plot whatever number is equal to 0 on the top or the bottom. Or is it equal to 0? So negative 2 is the only spot that I need to have there for a division to test to see what's going on. What's a number to the left of negative 2 you can plug in? Sure, let's plug in negative 3. Negative 3 plus 2. Negative 1 cubed. Negative 12 divided by negative 1. That's a positive. What's a number to the right of negative 2 to plug in? And I get negative 12 over 2 cubed. Is that going to be positive or negative? Negative. So see, I don't necessarily even care about the values. What I do care about is whether or not it's positive or negative. What does that tell us about up here? Concavity. Tell us about concavity. It's going to be concave up from negative infinity to negative 2. It's going to be concave down from we would like to say the inflection is negative 2, but is negative 2 part of the domain? It is not. So therefore, there is no point of inflection. So as you look at this, negative 2 would give you 0 in the denominator, right? So it cannot be included as a point. If you plug in negative 2, you don't get any output. Excellent, excellent question. We start with the vertical asymptote. I'm going to make an 8 by 8 graph. 2, 4, 6, 8, 10. Make a 10 by 10 graph, sorry. 2, 4, 6, 8, 10. We have a vertical asymptote of x equals negative 2. What do you want to graph next? The horizontal asymptote. Bree, I'm going to ask you to grade me when I'm done, okay? Yes, sir. Answer key? That's fine. Yep, I'll look through your work on the test and I'll make sure that I understand and get it right. And if I get it wrong, just let me know and we'll make the change. Okay, what would you like to plot now? What is there to plot? You still have something up here you can plot, folks. The intercept. Your intercepts happen at 0, 0. So this graph is always increasing. So if it's increasing, will it be in the bottom or will it be in the top? It will be in the top. Okay, let's piece it together. Is this concave up or concave down? It's concave up. Does that match with what we put? Yeah, it does. Let's look at the next one. The next part, it says that it has to be increasing. So if it's increasing, will it be in the top or will it be in the bottom? It'll be in the bottom, right? Because this is increasing, and it goes through there, and it's concave down. See how all of those match together? No, okay. No. You're asking a really good question. Let me see if we can clarify this because it's a really good question. Okay? Suppose that I have a graph of f prime. Suppose that that's the derivative. Okay? We would say that that means that the original function is increasing from 1 to infinity because that's where this is above the x-axis. Agreed? But the original function may look something like this. See how the original function is below the x-axis, but it's on its way up from here on over? From 1, that way it's on its way up. So similarly, you can see in this example right here, increasing, I'm always on my way up. If you looked at the graph of the derivative would always be above the x-axis. Can I show you the graph of the derivative really quick? Here's the graph of this derivative. That's the derivative. See how it's always above the x-axis? So that means that this is always going up. That's what it means. Okay. All right. That is your final example. I do want to show you what's ahead of you so you can understand. Okay. We're not going to do this problem right now. Okay. And we are not going to do this problem. So I've reduced it to what I feel is most essential for our work, which means that if you turn in your assignments, problem 6 is optional. Optional. And so are 7 and 8. And then if you turn in your study guide that I just handed to you, problem 13 is optional. Well, if you are curious about how these shapes work themselves out, I would highly encourage you to give it a shot. We forgot to do one last piece. We need to make sure that Bree can grade me. Bree, you really want to grade this, didn't you? Okay, we're going to check this out. I take out my calculator. And Bree, can you tell me my original function? I have y equals 3x. And that was a 10 by 10 graph, wasn't it? Negative 10 by 10, and then the tick marks were every 2. Negative 10 and 10. Tick mark every 2. And I look at this graph, and I've got this guy right here. Let's see how accurate it is. Bree, are you ready to grade me? Out of 100. Okay, I got a 98. I'll take it. I'll take it. I agree. It could be better. It'd be kind of cool if I could see the horizontal asymptote, couldn't I? So what if I did this? What if I just put the horizontal asymptote in there and change that to a dotted line? A little better? Maybe. All right. Rest of the time is yours. I'll put the XKL line. The study guide is slightly new from previous years. I'm going to have to work that guy out tonight. Question? Yeah, so you've got so you got 0 and 0, right? Because it's squared, double root. So she's not on the derivative yet.